There is exquisite fine tuning and rare circumstances that have to be in place for a planet to be able to support life. So, complex, intelligent life needs remarkably unique and very rare, exquisitely fine tuned conditions. Remember the claim, though. Well, if there's enough stars and planets out there and enough time, then life must exist somewhere, right? Well, actually, no. And I want to try to explain a little bit about why. So, think about what is required for a planet to support life. Well, first, there's the actual rotation of the planet itself. If the rotation is too fast, we would have out of control wind conditions. Too slow, we would have extreme temperature variations between night and day, and life couldn't exist. What about the sun? Well, the sun itself, the distance to its nearby planets is critical because of the heat and radiation given off, right? So if the sun is too large, the chemical reactions would be too rapid, too much radiation. If the distance to the sun is too far, then the water cycle is disrupted. There are all of these complications, but it's really the planet's ability to reflect radiation from the sun, to absorb with the correct rotation and the correct distance to the sun, which is its star that it's associated with. Right off the bat, you're eliminating over 99% of all the planets that could be found in the universe. So we're narrowing the list of available planets incredibly, just with some basic criteria. Some other thoughts is that the planet and its nearby star have to be rich in heavy metals to support the formation of rock and for the proper minerals and building blocks of life to exist. And that's not true everywhere. What about gravity? So if gravity was too weak on this planet, then water vapor would escape out into the atmosphere and not be available for the water cycle. If gravity was too strong, then we would retain toxic, noxious gases in our atmosphere, and life couldn't exist either. How about the actual orbit, the shape of the orbit, the tilt of the Earth has to be exquisitely precise for seasons, for temperature variation, and so forth. The magnetic field of the Earth that deflects charged particles coming from the sun to protect us from radiation has to be precise. And then there's the recycling of minerals through volcanoes and seismic activity. As water runs off into the ocean and brings minerals and nutrients with it down into the ocean, the tectonic plates will actually bring these down into the crust and then uplift them back. So there's this recycling requirement that the planet must have. And some other things you might not have really thought of, but the proximity to nearby huge planets that we call gas giants. This here is Jupiter, but Saturn is another, and so is Neptune. So, what's the significance of nearby gas giants? Well, basically, a giant planet that is neighboring where life exists serves many functions. So, as comets and asteroids and meteors are hurtling through space, these large, huge gas giants will actually, by gravity, pull those objects towards itself and deflect them off of, in our case, the Earth. So a planet that would support life would have to have nearby larger planets in order to perform the same function. But if those outer planets are too close, then that would disrupt the planet's orbit and cause all other kinds of problems. So there has to be exquisite positioning of nearby planets and bodies in order to account for this. Atmospheric pressure is yet another. So if the pressure is too small, then there's also water evaporation complications and other things. So I think you get the point that there is exquisite fine tuning and rare circumstances that have to be in place for a planet to be able to support life. And there are many, many more that I'm not getting into, but this is just to try to give you some illustrations.